see how it goes. So let me open a Word document. Yeah, I saw your submissions, and I will go through them tomorrow and try to mark them as quick as possible. So it won't be that hard. So yes, let me see what we have for today. Okay, so but have you guys done cos and sine graphs? Are you guys familiar with the cos and sine graph?
Not on my side, sir.
Not on your side. Ma'am Swane?
No, not me either.
Okay, no problem. Because one mistake that teachers do is to start the topic of general solutions without explaining how sine and cos graphs look like. Because if you know how they look like, you'll be able to understand how the general solutions work. So I'm going to be doing general solutions. Quickly. Okay, a sine graph looks like the following. Okay, before I even draw the sine graph, I want to draw it with you guys. Okay, I'm going to use the following values. Okay. So the sine theta, okay, fine. So do you guys have calculators with you?
Yes.
Okay, so what is the sine of, what is the sine of 0?
It's 0.
0. What is the sine of 90?
It's 1.
1. 180?
It's 0.
0. Then 270?
-1.
-1. And 360?
It's 0.
And 0. 0. Okay. I'm going to do the same with the cos. Okay, cos of theta. What is the cos of 0?
One.
1. Cos of 90?
0.
0. 180?
-1.
-1. 270? How much did you get for 270?
I got 0.
0 and 360.
1.
1. Perfect. Okay. Now we have the tan. Okay. We are dealing with the tan. Do you agree that the tan of theta is given by sine theta over cos of theta? Do we all agree from there?
Yeah, yes, sir.
Okay. Okay. So what will be the tan of 0? It will be 0 over 1. I don't know if you agree. Use your calculator. Let's see. What is the
That's
tan of
0.
It's 0. Okay. And the tan of 90, which is 1 divided by 0. Use your calculator.
Sir, I'm getting a math error.
Okay. So it's undefined, right?
Yes.
Okay. 180 is going to be 0 divided by minus 1. So what are you getting?
0.
0. Okay. And then 270.
Undefined.
Undefined. Okay. Undefined. And 360.
0.
0. Perfect. Now I'm going to start drawing the graphs. Okay. That will be 1 and that will be minus 1. So if this is 180, 360, 90, 270, we are going to have, okay, the first graph, which is the sine, is going to look like this. Okay, that's fine. Then the cos graph will look like this. It started at 1. So it goes like that. So I just want you guys to realize what we were doing with, do you still remember that x will give us the cos of 90? Do you still agree? Do you still remember? No, the cos of x, sorry, cos of x. Do you remember?
Yes.
Okay. Do you see the distance between the two graphs? It's actually 90. Do you see?
So please
Yes, sir.
explain that.
The distance between the two graphs is actually 90.
Oh,
Do you see?
yes, sir.
Do you see the reason why if you add 90 or if you subtract 90, you can easily get a switch between sine graph and the cos graph? Because if you add 90, it means you are shifting your sine graph 90 degrees backwards. If you shift your sine graph 90 degrees backwards, you get to the sine. So this is where the relationship comes from. You can see it graphically. Okay. And then I want you to, okay, on your calculator, say a tan of 89 degrees. Tan of 89 degrees. What is the tan of 89 degrees? Romeo, the tan of
so it's 57.8 29.
57.8. Do you realize? Do you realize that the value? Do you realize that the value of tan? Okay, you got 57, right? Also
Yes,
try a tan of 89.5.
So that gives us 114.
And 114.
Yes.
Okay, again try tan of 89.9.
So that's 572.
572. 572. So I wanted you to notice something, that as soon as you increase the value of tan coming from 0, it increases drastically. But when it reaches 90, it becomes undefined. What does that mean? It means your graph will look like this. It will have something that we call an asymptote. Do you guys know what an asymptote is?
Yes.
Okay, yes. So a tan graph have an asymptote. It has an asymptote at 90 degrees and also at 270 degrees. So at 270, we're going to have something like that. Wait, no, this is not it. At 270, your graph does not touch 90 degrees. But it also does not touch your 270 degrees. So 270 will be your asymptote also. Then you will have another tail going down. So that's your tan theta graph. And then the black one is your sine theta. And then this is your cos. Okay, but however, what I have done there was just the sine and the cos graphs when theta is between 0 and 360. So this is your sine graph. Use your calculator and say sine of 720. What is the sine of 720?
0.
0. And what is the sine of, this is 180. What is 360 plus 180? Let's see. Uh, 360 plus 180. What is the sine of
540.
Yes, what is the sine of 540?
0.
0.
Mm-hmm.
Okay, let me see. And 360 plus 90 will be 450. What is the sine of 450?
1.
1. Okay, so I'm gonna draw the graph like that. So your 450 is round about there, 450 degrees. It's actually 1. Okay. So the graph that we're gonna be dealing with when we do general equations will be a continuous graph of sine. Just like the waves that you did in physical sciences in grade 10. The sine and the causes are a representation of the waves. Okay, so what we're going to be dealing with when we do general equations is to be able to find an equation which generalizes all the points that you will get after drawing a horizontal line. For instance, let's say you have an equation which says let's say if you have an equation which says sine of theta is equals to 1, and someone says find the general solution. Mamswan, what is the general solution of sine theta equals 1?
So
Yes.
I am not sure, but isn't it theta is equals to x sine 1?
Yes, that's true. So you have to go to your calculator and type arc sine 1. If you can see this symbol on your calculator, you press it and you press 1. So what is it that you're gonna get? Arc sine of 1.
It's
90.
90.
It's 90 degrees. Okay, so that is a particular solution, and that solution is a solution which is between 0 and 360. But with a general solution, we know that our graph at 90 degrees, this is where, where is it? Let me go to this one. At 90 degrees, this is 90 degrees. The value of sine of 90 degrees will give you 1. However, also if you type 450 times if you type the sine of 450, you will also get 1. The same way, if you type the sine of that value, you will get 1. So, Mamsan, how can I generalize this equation? To generalize the solution, we know that theta is equals to 90 degrees plus you can see that from that point to that one, how many steps do I have to travel? Or how many degrees, Mamswan? From here to here, how many degrees do I have to travel? Ronel, how many degrees from here to here?
So do you mean from 90 degrees to 450?
Yes.
360.
360. If we're generalizing it, we're gonna put a K. The reason why I'm putting a K is because, okay, how many steps from this point to that one? From here to here.
630.
630. You said 630 from there to the, no, it can't be. Isn't it 720?
From where to where, sir?
From this point to that one.
Oh. Yeah, then it has to be 720.
720. Yes, you agree, right? And 720, if I'm generalizing and putting 720 in this equation also, if I put 2 times 360 will give me 720. But if I put 3, what is 3 times 360?
1080.
Yeah, that's what I'm gonna add from that point to there. So generalizing means it's showing you what to add in order to get the next solution, which is the same. So our solution will be 90 plus 360 degrees, whereby K is the element of integers. What are integers, Mamswan?
So numbers that either have a positive or negative sign.
Okay. Yeah, that's true. So if we take K as 0, which point are we going to be talking about? We're going to be talking about this one. You agree?
Yes, sir.
Okay. If we say K is equals to -1, which point we're going to be talking about this point? So if it's -1, 90 minus 360 will give us
Negative 270.
It will give us a minus 270. So this is a minus 270. Okay, so that's how we find the general solutions. This is how we find the general solutions. So when you are dealing with the general solutions, you have to add 360K. If you are dealing with the sines, you add 360K, where K is the element of all integers. Are we all in the same page? Are we all in the same page? Okay. I'm going to give you another example. Okay, general solution. Okay, the sine of 30 degrees. The sine of 30 degrees is equals to Mamsan.
So it's equals to 0.5.
It's equal to 0.5. Okay, no, that's perfect. Okay. So what is the sine of 180 minus 30?
It's also equal to 0.5.
Okay. (180 minus 30 is 150. Equal to 1. So if you have been given an equation, sine of theta is, 0.5. 0.5. So if you have been given an equation, sine of theta equals 0.5. What angles are we looking at which are within 0 and 360? Or let's start with the angle which is between 0 and 90 degrees. We're gonna do the same thing. We're gonna say sine, then we press 0.5. What is it that we got?
$30 degrees.
30 degrees. That's one of it. So we're gonna have 30 degrees and 180 minus 30 degrees. This always applies when you're dealing with sine graphs and when you are trying to find the general solutions. So the solution is always the angle and 180 minus the angle. These are the solutions. And then from there, because it is 30 and 150, our solution will be theta equals the angle plus 360 degrees times k, where k is the element of integers. However, we have two angles in this case. So the second angle will be 150 degrees plus 360 degrees k, where k is the element of integers. So the observation that you're going to find from the graph is that if you're dealing with a sine graph, if you draw a line at 90 degrees, this portion of your graph is symmetrical. So if you have 30 degrees there, and if that's 0.5, if you draw a line, it will cut two places within the 180 mark. It will cut two places within the 180 mark. And to get the value from here to there, you just go and say 180 minus this portion, which will take us back to this point. But ultimately, if you have to cram, so be it. If you are dealing with sine graphs, these are the general solutions. If you are dealing with the sine graph, the angle is given by plus 360 degrees K, and okay, that's where it ends. And if you are dealing with the cos graph, and let's say, let me give you an example. Cos of 60 degrees. What is the cos of 60 degrees? What is the cos of 60 degrees?
Zero 0.5.
0.5. Zero comma 5. Okay. Now let's say if the value of 0.5 is somewhere there. Okay, this will be 180. I am trying to find that value there. So in order to find that value, 360 minus 60, what is it?
300.
300. Okay, what is the cos of 300?
.5.
Okay. So the general solutions for cos will be it will be the angle that you get plus if you add 360 degrees, you are most likely going to land on the same value. So again, it will be plus 360 degrees k, where k is the element of all integers. And also 300, in order to get 300, we said 360 minus the angle plus 360 k. Where k is the element of all integers. So if you have to cram, so be it. The general solution of a sine graph is given by the angle plus 360 degrees and also 180 minus the angle. But with the cos, it's 360 minus the angle plus 360 k. Let me go to examples. I just want to find an example quickly. Okay. Okay. Let me okay. An example of a general solution. 9.1. Sine x is given by minus 3.125. So, Mamsan, what is the angle that we are looking at?
So wait, 3 point.
You're gonna have to type.
It's giving me a math error, so it's undefined.
Undefined.
Yes.
That's correct. There's no angle. If you have a standard graph like the one I've drawn, this graph, the maximum of a standard sine theta or a sine x graph ends at -1 and 1. You agree?
Yes, sir.
So, okay. So try 1.5 and see if you're gonna get an answer. Did you get an answer? Did you get an answer? If you press 1.5, what do you get? Do you get
So it's
anything?
also undefined.
Yes. Yes, it is because under a normal sine x or a sine theta graph, which has a maximum of 1 and a minimum of 1, the value 1.5 is beyond, it's above the graph, so it's not covered. Okay, let us try. We have cos of x minus 0.986 is equals to 0. This will be equals to cos of x. If I take 0.986 to the other side, I will have 0.986. Then let's try. Let's see. Ronel, what do you get?
So I get 9.59.
9.59. Okay.
How many decimal places?
You can take 2.
Oh, okay, then you can just leave it as it is.
Okay, 9.59 degrees. Okay, so the general.
Sorry.
Yes.
Right, and then that's the one things. And to
Okay.
Wait.
So the general solution will be, what will be the general solution, Ronel? Let me show you where my solutions, my general solutions were. Okay. This is for sine theta. This is for cos theta. We are dealing with a cos. So the first general solution will be the angle plus 360. The angle that we got is 9.59 plus 360 degrees. K, where K is the element of all real numbers. The second one is x is equals to 180 minus the angle 9.59 plus 360 degrees K, where K is the element of all real of all integers. Sorry. Any question? There's a question. Oh, yeah, you're right. We're dealing with the sine, with the cos. So with the cos is 360 minus the angle. Do we agree? Mamswan, you agree?
Yes.
Okay. So 360 minus the angle will give us 350. 350.41. So it'll be 350.41 plus 360 degrees K, the element of all integers. That's fine. So any question? I don't think there's any question. This is simple and straightforward. You just use your calculator. But I just want to show you where to find this in your graph. Where are my graphs? Okay. Where is my standard graph? Yes. This is our course graph. This is our course graph. If you say the course of 0.9, 0.9 is around here. So if I draw a horizontal line, it is going to cut somewhere there where your angle will be 9.59. However, if I continue drawing this horizontal line, it is going to cut somewhere there, which according to our general solution, it is 360 minus the angle, takes us back to that point. So these are the 2 points you will have when dealing with the cos graph. Now, the reason why when I did the first example of sine of 90 degrees, the reason why I only used one general solution. Mamswan, why do you think I only used one general solution for the sine of 90 degrees instead of two?
So please repeat your question.
Why do you think I used one general solution for the sine, for sine theta equals 1?
So because there is no other angle that gives you 1.
Okay. Let me do it using what we have. So you agree that we will have the angle which is 90 degrees, right? And
Yes.
the second equation will be what?
The second equation for
your general solutions.
180 minus 90.
Which is what?
Which is 90.
Do you see why I didn't bother considering the second equation?
Okay, yeah, I see now.
Yes. Okay. I'm glad you understand. Now, we are done with this one. Let me bring a few more examples before we start with the turn. Okay. Okay, let me put it there. Okay, 9.5. Ronewa, how do we deal with this one? 2 cos x plus 1 equals 0. Where do we start? Where do we start? Mamswan.
Sir, should you not transpose one to the other side first?
Perfect. It's gonna be
-1.
okay, and then
Divide by 2.
Cos of x is given by
-0.5.
and from here
Transpose cos to the other side, which is arc cos.
arc cos of minus 0.5. What is the arc cos of minus 0.5? Simple
120.
calculator. It gave you
120.
120 degrees. Okay. So our general equation will be, we are dealing with a cos. So the angle will be 120, you agree? Plus
Yes.
360, k, where k is the element of all integers. And then the second one will be, yes.
Will it not be minus because we're dealing with a cos?
The minus of the angle.
Not 120 minus, or 360 minus 120.
You said 3, I'm just doing it a trial and error. You said 360 minus 120. Okay, no, that's perfect. So plus 360 k. I'm lazy to repeat the same thing, but it's fine. Okay, this will be 360 minus 120. How much do we get?
240.
240 plus 360 degrees times k. Again, k is the element. Hey, I'm lazy to write this one, but it's fine. Yeah, so we have two equations. We have the first one and the second one, and that's it. Gudo, do you have any question? Any question? Okay. Since there's no question, I'm gonna move quickly to turn. I'm gonna try to overlap time since I don't have any class in the moment. I'm gonna overlap it maybe by 25 to 30 minutes. As long as I've covered all the functions. I'm done with sine and cos. Now we're moving to tan. What you will notice with the tan graph is that it has asymptotes at 90 degrees and 270 degrees. So this will be 360. If you add this portion in that one, you will have a complete cycle. But that's the story for another day. You can also extend them if you want. So this will be minus 90 degrees. So if it's minus 90, we will also have minus 180. But before we move on, I don't just want to draw this graph. Okay, Mamsana, can you type? Can you type, let's say, the tan of minus 180? I just want to be sure that we're talking about this. Same value. If it gives you 0, I think I'm correct. The tan of minus 180. What is the tan of minus 180?
It's 0.
It's 0, so I'm correct. So try the tan of minus 90.
Undefined.
Undefined again. You see, they continue up to infinity. All these asymptotes up to infinity. So again, we are trying to generalize the solutions that we're gonna get. Let's say, for instance, if I draw a horizontal line there. Okay, what is the distance from there to there? Romeo. Or what is the change in angle? Let me say that. From here to there.
From where to where, sir? I can't clearly see your indications.
From this point to this one.
So from 90. Oh.
Okay, let me say from this point to that one.
Isn't it 180, sir?
It's how much? 180.
Yes.
Yeah, so basically what I did was I was trying to find the distance between the 2 points on your graphs that are in phase, These 2 points are in phase. So the distance between them is 180. So we are very lucky that when dealing with tan functions, if you have the tan of an angle equals, let's say if the tan of an angle equals theta, unfortunately or fortunately, we will only have the angle equals plus 180 degrees. K, where K is the element of all integers. So for tan, it's only the angle plus 180. That's your general solution and nothing else. Are we all in the same page? Ngudo? Oh, you have any question?
No, sir.
Okay, no problem. So I'm gonna bring an example. Which is going to be very easy. Okay. Okay. Ronel, we have 9.3, which is 3 tan x equals 2.12. Where do we start?
So you could start by moving or dividing both sides by 3.
Okay. Then what do we have?
So then you have 10x is equals to 0.71.
7.1. Okay, and then the angle?
Then so we can say x is equals to arctan 0.71.
Yes.
And then that's gonna give us x is equals to 35.37.
35.37 degrees. Okay, the general solution?
So that would be
Let me go back. These are my general solutions.
okay. So would it be the first one?
It will be, we are dealing with the term.
Yes.
Yes.
Oh, so x, theta is equals to x.
You saw it, ne?
Yes,
Can I
sir.
go? Okay. So what should I write?
So you can write theta, x is equals to so I'm actually not sure where to go from here.
You just take the angle.
Yes.
Okay. 0.37. Then you remember the structure of our general solution was, okay?
Yes.
It was plus what?
Plus x.
You agree?
Yes.
It's very easy. You just go and copy the structure. That's it. So what you must know is that with sine, cos, and tan, whatever general solution I've put on our notes, you just copy it as it is. It doesn't change. Okay, 9.4. Mamswan. Tan of x equals sine of 35 degrees. How do we go about this one?
So
Yes.
would we have to solve for sine 35?
Which the sine of
Which-
35, which is?
Which is 0.57.
Sine of 35 is 0.57.
57.
Okay, so tan of x. So okay, we have the value. So what angle do we have?
We have 29.68.
Okay, and then from there, my general solution.
That's gonna be x is equals to 29.68 plus 180 degrees K. And then, yeah.
Yeah, that's it. So it's that easy. Let me give you a more complicated examples. Okay. Okay. Try the first. Let me see. We still have more spaces. Okay. Mamswan, the first one. How do we go about it? Ronel, how do we go about it? Oh yeah, she's back. Okay. There's an internet problem on their side. Okay, well now how do we go about it?
So this one. So do we so should we divide both sides by 5/9?
I'm gonna do that. So if I divide by 5/9, I will have minus, okay. I will have minus sine of x over 5/9. Okay. And from there, from there,
But I'm not sure about this one.
okay. Now the aim of the general solutions is you need to ensure that you have one ratio, either a sine or a cos or a tangent. Don't you think we can combine the two and make a tan? Don't you think? Don't you think we can?
Yes, sir. Possible.
Okay, so how do we do that? So if we divide by cos of x, both sides, what are we left with? We are left with 5/9 is equals to minus, what is sine of x divided by cos of x, Ronel? What is sine of x divided by the cos of x?
But it's 10 x.
Perfect. So we will have minus, you agree we're going to have a minus tan of x, right?
Yes, sir.
Okay. Okay, yes. So we're going to have 5/9 equals minus tan of x. So from here, what can we do? From there.
So would it help to make the 10x positive by taking it to the other side?
It will help a lot.
Okay.
So what do we do? Okay.
So you can just write 10x is equals to negative 5/9.
Okay, you want to take tan x to the other side?
Yes, to make it positive.
Minus 5/9. You agree with that?
Yes, sir. And then we could say x is equals to 10 minus 5/9.
Which is?
Which is negative 29.05.
Negative 29.05.
9.05. Yes.
Degrees.
Yes. And then we could say x is equals to
Okay, x is equals to
negative 29.05
negative 29.05
plus 180k.
8k. Perfect. Perfect. The second one, I'm trying to see if Mamswan has connection where she is. She's struggling with connection. Okay.
So,
Ronel.
So I was gonna say on my side it says that she's waiting in the lobby.
Is it? Are you able to accept her? Do you have that permission?
Okay, I'm trying to admit her. We'll see.
Yes, because on my side it's saying admitting, it's not going through.
Yeah, same. It's also not going down the side.
Yeah, I think she's having a network problem. But luckily we are recording, so I'm gonna upload some of it. It's just that I haven't gotten time to upload, but I'll try to upload everything in bulk. Okay, the second one, Ngudo. How can we solve 9.13? Okay. Okay, I think
So
yes, Ramya.
I have an idea, but I'm not sure if it would work. What would happen if we decided to take the right hand side to the left and equate it to 0?
The right hand side. You said the right. Okay,
The left hand side. So the sign is going to become positive on the other side.
Okay. Let's see. You said 9.13. You said if we take the sign to the other side.
Yes, and then equate it to 0. What would happen?
Let's see. That cos of 3x plus 20 degrees and then plus sine of x minus x minus 60 degrees is equals to 0. That's a brilliant idea. Then from here, what do we do?
So then is cos x not equals to sine 90 degrees minus x?
That's true.
So would we say?
Okay, I think this is what you are looking at. So which one do you want to change? Do you want to change this one or this one?
I want to change the first answer. I want it to become sine.
No problem. I will do as you please. So what should I write?
So could you write sine?
Okay, so it's gonna be sine.
Okay.
It's gonna be sine of
90 minus, and then put the brackets and just copy down 3x plus 20.
Okay, and then plus
sine x minus 60 is equals to 0.
Okay, yes, this is where we are right now. Okay. So this will be sine of 90 plus 20 will give us 110 minus 3.
So is it not minus?
Oh, it's a minus. Yeah, you're right. So it's going to be a 60. Then 60 minus 3x.
So it's going to be 70.
70. My math. It's not mathing, but it's fine. Okay, this is what we have. And plus sine of x minus 60 degrees will give us 0. Okay.
Yes, I don't know what to do after this.
Okay. So, okay, but you were on the right track. Okay. So I'm just gonna start where we were. So it's gonna be cos of 3x plus 20 degrees is equals to the sine. It's actually a minus sine of x minus 60 degrees. Okay. You have okay. So do you know any quadrant whereby sine is negative? Where sine is negative. Or let me just say, do you know any, let me use what you wanted to use. Let me use this side. Do you know any quadrant where the cos is negative? Because I am trying to match that negative there. Do you know that quadrant? It is the second quadrant. Do you agree? Do you agree that the second quadrant will have your cos as negative? Ronel, I'm struggling. I'm struggling to hear you.
So can you hear me now?
Yes, yes.
Okay, so my question was, how did you manage, or how did we cancel out the third quadrant? The answer.
How did I cancel the
Third
third
quadrant, because
quadrant?
cos is also negative than the third quadrant, so that makes us say that it's the second one. So
Yes, you are right, but at the same time, I want to match the negative, and at the same time, I want to transform cos into sine. And the only way I could do that is to add or subtract 90 degrees. And if I add 90 degrees to an angle which is in the first quadrant, I will go straight to the second quadrant. The only way cos can transform and become sine is when you are dealing with 90 degrees. Do you agree?
yes, sir.
Okay, so do you see why I've chosen the second quadrant?
Yes, sir.
Okay. So the cos of that angle will be the minus of it will be the minus of sine of, if you're dealing with the second quadrant, if you're dealing with the second quadrant, we're gonna have the sine of 90 plus that angle is equals to sine minus sine of x minus 60 degrees. Okay, what do you notice? We have a minus on this side and a minus on the other side. Can they cancel? Ronewa, can they cancel?
I don't think so, sir.
You don't think so?
No.
Don't you think this is a minus 1?
Yeah.
Can't I divide by minus 1 both sides?
Oh,
And
yeah.
I will relieve the minus.
Yeah.
Oh, it would become positive.
Okay, now that I have the 2, what comes to your mind now? Ronel, am I allowed to say that 90 degrees plus 300 plus 3x plus 20 degrees is equals to x minus 60 degrees? Am I allowed?
Yes, sir, I would think so.
You think so? Why? Because it's sine on both sides.
Yes.
Okay, so we have 90 degrees plus 20, which is 110 plus 3x is equals to x minus 60 degrees. Okay, you have 3x. If you take x to the other side, you will have 3x minus x is equals to minus 60 degrees minus 110. Okay. So what is this? Will be 2x is equals to minus 60 plus 110 is what?
Negative 170.
Negative 170, yes. And
Yes.
then x will be
Negative 85.
minus 85 degrees. However, like I said, we are dealing with the sine. So if you are dealing with the sine, it's going to be x equals minus 85, then plus 360 degrees, where k is the element of integers. And the second equation will be do you still remember? Or should I go back? Let me go back. The second equation will be Ronel.
Yes, sir.
The second equation will be
So would it am I answering the question we're doing now according
Yes.
to
according to the standard of general solutions.
okay, so then it would be x is equals to 180 minus 85 plus 360k and then k is an element of integers.
Okay, so this is going to be 180 plus minus 85. So 180 plus 85 will give us
265.
265 plus 360 degrees K. I'm lazy to write that. So the angle that we got was minus 85. I just wanna see if what we did was correct. Take your calculator and say cos of 3 times minus 180 plus 20.
Then that gives me negative 0.994.
Okay, so it is okay. Let me see. 3 times 3 times minus. Oh, both of them.
I only did the cos side.
Okay, so it gave you a minus. It was a minus. You said minus 0.
No way.
Minus 0.573, right? So this is the left hand side. Let's check the right hand side. Sine of minus 180, minus 85, sorry, minus 60.
So that gives us positive 0.573.
It gave you a positive number.
Yes. It's the same number, but positive.
But positive. Oh. Okay, okay, very interesting. Okay, let me see. You're right. Just want to see where we went wrong. Okay. Okay, I see. I see. You are, no, you're right. I see. So the third, actually the fourth quadrant is where our cos is positive. Is it true? You agree?
Yes, sir.
But the sign is a negative.
Yes, sir.
Okay, so let us try this one. Let's see. So in the fourth quadrant, you will have the angle, which is 3x plus 20 minus 90. Minus 90 degrees. So if we equate the two, let's see what we're going to get. We're going to have let's see, 3x plus 20 degrees minus 90 will give us that. So this will be 20 minus 90, which is 3x minus 60 degrees. Is it 60? Sorry, 70.
Yes, sir.
Yeah, 70. Okay. 70 is equal to x minus 60. Okay, fine. If we take x to the other side, we will have 3x minus x is equals to minus 60 degrees plus 70. So 2x is equals to
10.
10. Okay, so x is given by 5 degrees. Okay, 5 degrees. Okay, sharp. Let's replace 5 degrees. 5 degrees instead. So cos of 3 times 5. Plus 20. 0.8. Oh, how much did you get?
Should I get for what, sir?
Hmm?
For what?
On the left-hand side, if you replace x by 5, how much are you getting?
Sir, I'm getting 0.
How much?
Sir, I'm getting 0.82.
0.8. You said 8 to 1.
Or, no. Okay, it's 819.
9. Okay. Now let us do the right-hand side.
So that's gonna give us 0.819.
which is positive.
Yeah.
Okay, so do you see the solution?
Exactly.
Yeah, so we are bound to make mistakes. I do make mistakes here and there. So I'm not a superhuman. It's just that I have to go back and rectify and check if the answer is right. So our answer is +5. Here we will have -5. So -5 will give us 180 minus 5 will give us 175. So I think if you get time, then when you get to the exam, this one you have to relook at it maybe 2 or 3 times because it's one of the tough questions. You're rarely gonna get it, but if you get it, it consumes a lot of brain, I think. And most of the people won't get it in the exam. Okay, let's do the last one. 3 tan x equals 2 sine x. 3 tan x equals 2 sine x. Let me check. 2 sine x. Okay, perfect. 2 sine x. So, Rhonda, where do we start? Because the end goal is to make sure that we have one co-ratio. Where do we start? Where do we start? One, five. Okay. Do you agree that we can break down the term into sine of x over cos of x? Do you agree? Okay. 2 sine of x. Okay, perfect. So from here, what can we do?
So you can equate everything to
We can
equate everything to 0.
okay, but we already have an equal sign.
So what if we
Hmm?
so I'm saying what if we 2 sine x to the other side?
Or by dividing by sine x. Ronel, you mean by dividing by sine x?
So,
Yes.
so I'm not sure. So could we not just write it as 3 sine x minus 2
Or you want it to come to this side? No problem.
yes.
Then no problem. Equals 0. Okay, from here.
So would we put it all over a common denominator, which is cos?
Yeah, that works as well. Then what will be our LCD?
Cos x
Okay, and then this will be minus
2
and then
times cos x.
perfect. Okay, so from here.
So then would we not just say 3 sine x minus 2 sine x times cos x is equals to 0?
Okay, I agree with you, because if we multiply by cos, we'll get that. So
And then so then because it's two separate terms, so could we factor out sine x?
no problem. 3 minus what? Minus 2
Cos x.
cos x. Perfect. Okay. Then from here,
And then we can say sine x is equals to 0, and then 3 minus 2 cos x is equals to 0.
and 3 minus cos of x equals 0. That's perfect.
Okay, and then on that side, x is gonna be 0 because sine or arc sine 0 is equals to 0.
Okay, this is 2, no? You agree?
Yes, sir.
Okay. Okay, so your x will be
0.
the angle will be 0.
Yes, and
So
then
0 will have x equals 0. 0 plus 360 degrees. Okay, and the second statement will be, we are dealing with a sine, by the way.
and then the second statement is gonna say x is equals to 180 minus 0
Which is
plus 360k.
okay. And then from here,
And then on that side, we can take the 3 on the other side, which is gonna be negative. It's gonna be negative 2 cos x is equals to negative 3.
negative, let's say, okay, let me say cos, you said negative cos of 2 cos of x equals minus 3. Okay.
Yes, and then we can divide both sides by negative 2.
Then cos of x is equals to
3 over 2.
which
And
is
then
okay, 3 over 2. Okay, now let's do the angle.
so
Yeah, if you get the angle, I'm gonna buy you I'm gonna buy you a car. Yes.
so you see, now it's impossible to say because the answer is undefined.
Okay. Okay. Okay, I'm just joking. So the only solution we're gonna be dealing with is this one. You agree?
Yes.
Okay. That's perfect. Yeah, I like how you have grasped this whole thing in such a quick pace. It's impressive.
Thank you.
Yeah, so I'll see you guys tomorrow. Physics.
Yes, sir.
Okay. So I'm gonna mark your scripts tomorrow, and then we're gonna be doing what you guys have done in your scripts.
Okay, sir.
All right. Enjoy your evening, and if you're watching Mubango, enjoy. Do you still watch Mubango?
Yes, sir. I love it with all my heart, eh?
Okay, yeah, So I realized that I'm actually wasting your Mubango time. Let me also rush to watch Mubango.
No.
Yeah,
Yeah, okay.
sure.
Okay, bye, sir.
Bye.